Okay, so in this video, we're going to start to kind of tie in the ideas we've been talking about for those special angles of 30, 45, and 60, and 0 and 90, your sine, your cosine, your tangents, with what we call the unit circle. Now, the unit circle has the basic idea that the radius, right? We take the idea that the radius of the circle, that the radius is equal to 1. The other assumption that we take is we're going to relate sine to the y value, right? To the y value of these points. And cosine will be equal to the x value of each of these points, right? And we get the idea that we could create a triangle, right? So if the radius is 1, right? And we always start with this basic idea of the origin being here in the center. So if the radius is 1, this point here will be 0, 1. And if we were to draw a radius of 1 straight up, we would get a point of 0, 1. If we were to draw a radius straight over, we would get a point of -1, 0. And if we were to draw a point down, we would get 0, -1. So those are our 4 quadrantal angles, or 4 quadrantal points, right? Now, that would give me an angle measure of 0 degrees, or 360 once we go all the way around, 90 degrees, and then we have 180 degrees, come around here to 270, and again back to 360. So if we're measuring in this counterclockwise movement, this would be a 30-degree angle, a 45, and then a 60. We got the 90. This would be 120, 135, and then 150, 210, 225, 240, 270, 300, 315, and then the final one of 330 before getting back to 360. All right. So in each of these cases, right, we can imagine that this point here comes down to make a right triangle, right? So as you see, if this line here is 1, this has to be less than 1. So as we take that radius up to create a 30-degree angle here, our hypotenuse stays 1, right? This stays 1, but our distance from the origin has to decrease. So it's getting smaller. And while our distance from the x-axis, our y value, will increase, right? So our y value increases. Remember, we had 1 over 2 was our first y value for the sine of 30. And our x value was the square root of 3 over 2. Now if we were to continue up so that here my radius still remains 1, but now you see that the distance from the origin to this point, to this x value, has gotten smaller, right? Which represents the square root of 2 over 2. While the distance to the y axis, right, this distance up has increased, where previously it was here, now it's gone up. So from 1/2 to the square root of 2 over 2. And then finally, if we're talking about this 60-degree angle, again the distance to the x value has gotten smaller. So from square root of 2 to square root of 1 over 2. And the distance to the y on the y-axis has increased. So that gets us the square root of 3 over 2. Until finally we get to our quadrantal point of 0, 1. And then as we move away, right, we continue in this direction, right, we look here at the x value and the y value, and we see that there's kind of a mirror going on. It's the exact same height as this one, so root 3 over 2, and that's going to be paired with a 1/2. So again, these pairs always match with each other. And as we continue here to the 135, we see that the height is the same, and this x value is the same. So root 2 over 2, root 2 over 2. And then here we have the last one here, this point here. And we see that this is going to be root 3 over 2 and 1 over 2. Now, notice that as we go up, the y values increase while the x values get closer and closer and closer. And then as we hit past the 90, the x values increase and the y values decrease. Now, keep in mind that on this side, this quadrant, right, the x values are negative. So we have to include the negative values, right? Negative 1/2, negative root 2 over 2, negative root 3 over 2, all the way to negative 1 over 0, right? And then we're going to continue around again. So after we get to negative 1, our x values are going to start to decrease again. But it's still in the third quadrant, right? This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in quadrant 3, our x values are negative, and our y values are also now negative because we're below the x-axis. So that's a negative 1 over 2, and then negative 2 over 2, sorry, negative square root of 2 over 2, negative square root of 2 over 2, and then we get down here to negative 1/2, negative root 3 over 2. And then we can continue around where our y values remain negative, but our x values become positive. So we get 1/2 root 3, negative root 3 over 2, root 2 over 2, negative root 2 over 2, and 1/2 negative, excuse me, root 3 over 2, negative 1/2, till we get to 0, 1, 0 again. All right, so here's our unit circle with these values, with this sort of alternating values between x and y. So we can go back to this idea of a much larger table and look back at the sign. Remember we said sign starts with 0 and then counts up 1/2, and then root 2 over 2, root 3 over 2, 1, and then it starts to count backwards, root 3 over 2, root 2 over 2, just 1 over 2, which is the same as root 1 over 2. Remember that relationship, to 0, and then it goes negative 1 over 2, negative 2 over 2, negative 3, root 3 over 2, and negative 1. Then it starts to count back, negative 3 over 2, negative root 2 over 2, and negative 1 over 2, back to 0. Whereas cosine does the opposite. 1, root 3 over 2, root 2 over 2, 1 over 2, and then it gets to 0. And then it goes into the negatives. Negative 1/2, negative root 3 over 2, negative root 2 over 2, negative root 3 over 2, and then negative 1. Once it hits that, it continues, it's still in the negative realm, so negative root 3 over 2, negative root 2 over 2, negative 1 over 2, to 0, back to 1/2, root 2 over 2, root 3 over 2, and then back to 1. Tangent follows a very particular one, right? It goes 0, root 3 over 2 over 3, 1, root 3, undefined, and then it goes back to root 3, but it's negative, and then we have negative 1, negative root 3 over 3, and then we have 0. And then we go back to positive, root 3 over 2 over 3, 1, root 3. And then we have undefined. And then we're back to negative, negative root 3, and then we have negative 1, negative root 3 over 3, and then we have 0 again. So that's our larger pattern, and once you start to kind of see the way that works, you got to kind of question why, and that's what gets us into what's called reference angles, and we'll talk about this a little bit more, but basically this pattern of 0, 30, 45, 60, 90 repeats itself. So this 60, or this 120 is really a reference angle of 60. 135 is really a reference angle of 45. 150 is a 30, right? Notice how the numbers are the same for 120 and 60, right? So that's why we call them reference angles. 180, right, is the same as a 0. And then we go again, 30, 45, 60, 90. Then we count down, 60, 45, 30, 0, right? So you see the angles count up to 90, then they really start counting down to 0 when we start talking about reference angles. Then they count back up, then they count back down. And if you look at the angles, the pattern of that through that lens, you start to see how that all kind of makes sense, right? And then again we have that whole pattern, right? So we'll talk about reference angles and how to figure those out in future videos. Have a good day.